Okay, we're going to start section 2.5 today. This is typically a pretty tricky lesson for students. This is kind of one of the first lessons we go over in Honors Algebra 2 where we start running into something that isn't really review for you. So what we're going to be studying here today is we're going to be looking at scatterplots, how that kind of tells us the relationship between two variables. And then we're going to look at how to get the line of best fit, a linear regression, but we're going to be using a lot of features on the calculator. This is very important that you have your TI-84 calculator handy today. I'm going to be demonstrating some things, and it is typically normal to feel a little bit overwhelmed at today's lesson, but the more you practice these problems, you'll be amazed in a few days how quick you'll be with running a linear regression on your calculator. Okay. So one of the first things that I want you to do on your calculator, and this will be relevant here when we get into the problems, is I want you to make sure that your diagnostics are actually turned on, okay? So I want to show you how to do that. Typically, once we do this, we shouldn't have to do it again unless you have games on your calculator that you play or your batteries go and your RAM gets reset. Sometimes that messes with settings and it can inadvertently turn off your diagnostics. We need them turned on so that when we run regressions, it will reveal the R value, which we'll talk about what that is here in a moment. So on your calculator, if you could please, go into the catalog on your calculator. Okay, the catalog is underneath the 0 key, but you're going to have to hit the second button first, then pick 0 for catalog. Here is an alphabetized list of all the commands that are on your calculator. What you're wanting to do is you can either manually scroll down with the down arrow all the way down to diagnostic on, or if you hit alpha and the letter D, and I usually have to do this twice, alpha D, it will take you to the D's in the catalog, from which you'll just scroll a little bit further and look for the command diagnostic on. Okay. When you find that, you're going to press enter. It'll paste it into the home screen. You're going to press enter one more time. It's going to feel like nothing happened, but we actually turned on the diagnostics, and that will be helpful when we actually run these regressions on the calculator. Okay. So we're going to go back to the notes page here today. We're going to first just kind of talk a little bit. We're going to talk a little bit here about just bivariate data. Okay. What bivariate data is. Bivariate data is anytime you have data that is comparing two variables, okay? Like maybe you would compare someone's height and someone's weight, okay? So typically scatter plots are what you get when you graph bivariate data on a coordinate plane. Okay, so I have 3 scatter plots here illustrated for you. I want to talk a little bit about correlation, how your two variables, we'll just say height and weight for right now, could have a positive correlation. Your two variables could have a negative correlation, or it's possible that your two variables really don't feel like they have any correlation at all. And so first and foremost, I want you to be able to tell just by glancing at a picture of a scatter plot if it feels like those two variables have a positive, negative, or no correlation. So here's what you would be looking for. If it feels like the points in your scatter plot are kind of leaning in the direction of a positive sloped line, then that indicates that those two variables have a positive correlation. If it feels more like your points are leaning in the direction of a negative sloped line, that is when we would say the correlation is negative. And if there really isn't any rhyme or reason, but they're just very dispersed and spread out, that is when we kind of say that there really is no correlation between those two variables. Okay, the other thing that we often talk about when we talk about the correlation, which is really just a fancy word for the relationship of two variables, is we talk about the strength of the relationship between the two variables, or the strength of the correlation. Okay, the closer you see your points clustered together in a straight line, the stronger that correlation is. Okay, so you can see in this one picture here on the left, these points here maybe feel like they're a little bit tighter together than maybe the ones that are pictured here in this second graph. Okay, so we would say that this one is, a strong correlation. This one is also pretty strong as well. But as you start to get your scatter plots kind of spaced out there, that's when we say that the correlation is extremely weak, or we might even say that there's no correlation between those. Okay, I don't know, I guess I had this one saying that it was weak, but it's maybe just kind of moderately weak there. Okay, here's something else that is definitely worth mentioning. Sometimes you're not given a scatter plot to look at, but instead you're just given some phrases, okay? Things like, oh goodness, here. Let's see if I can get this scrolled a little bit here for us, okay? I'm going to give you some examples here of two variables that would have a positive correlation, okay? Let's say you were given the statement, and we'll just write this here, the more you drive, brother, the more gas you use, okay? Now, in that statement there, you'll notice a few key words here. More, which means as something's increasing, and then also the word more again as something is increasing. So as the more you drive, the more gasoline you use. That is an example of a positive correlation, okay? So if you didn't have the scatter plot to look at, and you only had this sentence to look at here, what you would want to look for are those key words there. Positive correlations are anytime as one variable increases, if the other variable also increases, that means that those two variables have a positive correlation. Okay? It also works this way. If as one variable decreases, it causes the other variable to decrease, we would also say that that is a positive correlation. So I could rephrase this and say the less you drive, the less gas you use, and that is still showing a positive correlation. I kind of remember it like this. When you guys learned about dividing two positives and how that's a positive, but you also learned that when you divide two negatives, it's also a positive. So that's what we mean. If both variables are going in the same direction, we say it's a positive correlation. Okay? Now, a negative correlation, I'll have you write this example down. We're going to say the more you brush your teeth, okay? The more you brush your teeth, the less cavities you will have. Okay, so I'm going to highlight our key descriptor words here. Okay, our words would be the more you brush your teeth. Oh, how does that affect your cavities? It's causing that to go down. And so in this case, we would say that as one variable increases, if the other variable decreases, then that's an example of a negative correlation. Okay, it also could be flipped. We could say the less you brush your teeth, the more cavities you would have, and it's still having the variables go in opposite directions. That's an example of a negative correlation. Okay? Maybe a statement that would show kind of no correlation could be something like comparing a person. Oh my goodness, I had these already typed here. Huh, okay, you probably noticed that. I gave a few other examples there. Okay, I already had those examples typed. But a person's weight and his or her last English test score, those would be two things that would have nothing to do with one another. So if you surveyed people their weight and their English test score and you plotted those points, it would probably look very scattered and not really show any pertinent relationship between those two things. Okay? All right, so now let's talk about how to find a line of best fit. And you're going to see all sorts of terms that refer to a line of best fit, and you need to understand that these are all synonyms and they're just can be used interchangeably to kind of describe the same thing. So line of best fit is one phrase. You also could hear linear regression or line of regression. Sometimes it's referred to as a prediction equation. Also, it could be called a least squares line. Okay, a least squares line there. Okay. All right, so I'm going to talk you through, there's kind of three things that we're going to do with these problems. We're going to take the data, we're going to make a scatter plot, but all the scatter plots that you're going to be making on your homework are all going to be on the calculator. Okay? It's important that you know how to use your calculator to make a scatter plot. Okay? Because we can look at that and we can kind of get an idea of if the correlation is positive, if it's negative, if it's somewhat strong, if it's kind of weak, all just by looking at the scatter plot. Okay, we're then going to use features on the calculator to give us the equation for the line of best fit, and then we can use that equation to make predictions, like future predictions. And then finally, we want to be able to classify what the strength of the correlation is. And the calculator will give us a number for an R value, and we will use that to categorize what the strength is. So I'm going to walk you through this. We're going to go through this first example slowly here, but please know everything that's in these boxes tells you exactly what you are supposed to press. I would definitely have this notes page handy and with you when you go to work on the problems tonight. It will guide you through how to do these things on those problems here, okay? All right, so looking at example number 1, it says this table here shows the percent of U.S. households that had internet access in each of these 5 years, okay? And you can see here, you know, the internet was just coming on the scene in the mid-90s, and as you get even just to 2007, which was a while ago, you can see how it really skyrocketed in the percentage of households in the United States here. Okay, so the first question is, it wants us to make a scatter plot, and we're just going to make the scatter plot on our calculator. So we're not going to graph this over here or use this. We're just going to make the scatter plot on our calculator, and then we will make a line of best fit, and we will describe the correlation. So let's start with making the scatter plot. Now, there's a really important piece of information here, and that is demonstrated right here when it says, let X be the number of years since the year 1995, okay? Very, very important. You'll see this in a lot of these problems. When you are presented with a table, typically your first row are the X values of your point, and the second row are the Y values, okay? But what's a little bit different about this is we're not supposed to use these years as our X value. We're supposed to let our X be the number of years since the year 1995, okay? So if you look at the year 1997 and you say to yourself, okay, how many years is the year 1997 from the year 1995? Well, that's 2 years. So I'm going to put a 2 over top of that. 2000 would be 5 years after the year 1995. Okay, let's see, I lost my note here. All right. 2001 would be 6 years. 2003 is 8 years after 1995. And then we're at 2007, which looks like that would be 12 years, okay? So when we type this into the calculator, we're going to use those digits as our X value and these percentages here as our Y value, okay? Now, here's what you're going to do on the calculator. Again, everything I'm walking you through is in that box right above that tells you how to make a scatter plot on your calculator. Okay, so you're going to go to your calculator, okay, where you're going to put the data, and I actually might have you just make a little note here to yourself. The X values will always go into L1, and the Y values will always go into list 2 or L2, okay? All right, so you're going to press this black Stat button, and you're going to want to select number 1 for Edit. Okay? Now, if you happen to have any old data stored into your calculator, and I'm just going to go ahead, and I already have this kind of preloaded with the problem here, but let's pretend that I already had some numbers in L1, and it wasn't these numbers that I'm wanting. When you clear out your list, this is what you need to do. You need to move the cursor on top of L1, you're going to press the clear button followed by the down arrow. And you need to know how to do that because when you go to do the next problem, you're going to have all the previous problem's data in your list. Okay? So I'm real quick going to go ahead and re-enter those X values that we just said back down into L1, okay? And you want to just take a second and type those X values in L1, and then these are the percentages, type all of those into L2, okay? So you might need to pause the video in order to do that, okay? Okay, once you have the data in L1 and L2, what you're going to do next is you're going to need to turn on your scatter plot. So you see right here in blue it says Stat Plot. You're going to press the second key and the Y equals button. Okay. Right now, all of my plots are turned off. You're going to pick plot number 1. You're going to need to make sure that you press enter over top of the word on. And then there are 6 types of graphs. I'm going to hit the down arrow here. You're going to want to pick the one that looks like a scatter plot with all the little dots there. Okay? You need to confirm with the calculator that your x's are in L1 and that your y's are in L2. Now, if that was anything, let's just pretend that it said that my x's were L3. Okay? How you fix that is underneath the buttons 1 through 6 are the L1, L2, L3. So if I need to change this to L1, I'm going to hit second and the number 1, and that would change that to L1. Okay? All right, so we've put the data into the calculator. We've turned on the scatter plot. Before you get ahead of yourself and hit the graph button, you need to first make sure that you're setting a window so that you can actually see the scatter plot. Okay? So I'm going to have you go into the window, and this is where we're going to adjust and get a good window here to be able to see this. Okay? So if you look back at your paper, you want to look at the x values that we typed into L1, and you want to say to yourself, what is the smallest x value that we entered? And if you look on the paper, the smallest x value we entered was a 2. Okay, so you want your x min to be a little bit lower than the smallest x value that you typed in. So I might choose 0 as my x min. Okay? Then you want your x max to be the largest x value that you typed in. I think we typed 12 in, so I might choose an x max of 15, and I'm going to choose a scale along the x-axis of counting by 2s. Now we're going to do the same thing for the y's. Look at those y values. The smallest number was 18. I'm going to go a little bit smaller than that and go 15. And then the biggest number was 61.7. I'll go a little bit higher than that and say 65. The bigger the gap between your min and max, the larger you might want your scale to be. So I'm going to count by 5s on the y-axis. Okay, the last thing before tapping graph, you just want to press y equals and make sure there's not any old equations typed into y1 or y2. Clear out any old equations and go ahead and tap the graph button, and here you will see what the scatter plot looks like. Now, if we only have this scatter plot to look at, I would definitely say that these two things, the years since 1995 and the percent of households that have internet access, it definitely feels like they have a positive correlation, and it feels like it's pretty strong because these are somewhat clustered together in a line. They don't feel majorly spread out. I do kind of feel like I see a little bit of a curve there though. Okay? All right, so that's how to make the scatter plot on your calculator. You'll do all that work on the calculator. Okay? The next thing that this problem was asking us to do is to find a line of best fit. Okay? So I'm going to have you back out of this screen. If you could hit the second button and the mode key, that's going to have you quit that screen. And now I'm going to walk you through the key presses for how to have the calculator give you the equation for the line of best fit. Okay? Now, there's a lot of buttons here. We're going into a lot of menus. Everything I'm telling you is in those boxes up above. Okay? So you're going to press that black stat key again. Okay? Now our data is already in L1 and L2. Okay? You're going to bump to the right to this calculate menu, and what we're wanting to run is, in this chapter, we're only going to be running linear regressions. We want equations of straight lines in the form y equals mx plus b. So you're going to pick option 4, linreg, short for linear regression. Okay? The calculator, instead of using an m for the slope, uses an a. So I'm going to pick option 4. Now, if you have a newer calculator like mine, this is how your screen will look. If you have an older 83 calculator, your screen probably looks different. Okay? If you hang on 1 second, I will show you what you need to type in. People with this newer calculator, you need to make sure that L1 is across from your X list, that L2 is where we put the Y variables. You can skip frequency list, but put the cursor across from store regression equation. Okay? Now, even if you have an older calculator, you guys also are going to need to know where to go. So pay attention to this part here. We are always going to have the calculator not just calculate the equation for the line of best fit, but we're going to have it take the equation and store it into Y1 for us so that we don't have to manually type that in. Because oftentimes our slope and our y-intercept are really big long decimals, and we do not want to round those and type it in manually. We want the calculator to use the whole value there. Okay, so what we need to place right here is we need to place the variable y1. This is where the calculator will then take the equation and put it wherever we're telling it to place it, which would be y1. Okay, so where do we find the variable y1 on the calculator? Well, it's underneath this black vars button. That is actually short for variables. Okay, now what kind of variable are we looking for? Well, we're looking for a y variable. So I want you to bump to the right to the y vars menu. All of these problems are functions. You're going to press 1 for function, and then right there you see number 1, that's where the y1 variable is. You're going to come on down to calculate, you're going to press enter, and you'll notice that it is giving you an a value, which is our m, our slope, a b value, which is the y-intercept. You won't need to do anything with the r-squared value. That's something that is discussed in AP statistics. But you will want to write down the r value. We're going to talk about what that tells us here in just a minute. All of the numbers, a, b, and r, you can round to 2 decimal places. So on your paper, what you would write down for the line of best fit is you would write down y equals 4.17x plus 17.72, and then write down that the r value was 0.92. Okay, now let me circle back to those of you that had the older calculators. When you chose linear regression on the calculator menu, it likely pasted this command into the home screen for you. Okay? What you have to do is you have to tell the calculator, this is where I put the x's and the y's, and this is where I want you to put the regression equation. Okay? So after the parentheses, you're going to put an L1 after the parentheses. Now, where do you find that L1? You're going to press the second key and number 1, and that's where you'll get an L1. Okay? After you have L1, you need to put a comma. The comma is right above the number 7 button. So you're going to do L1, comma, L2, so you're going to hit second and the number 2, put another comma after that, and then you're going to put the y1 variable there. So you're telling it, this is where I put the x's and the y's, and this is where I want you to put the equation. Okay, just a quick refresher, those of you with the older calculators, to get the y1 variable, it's the vars button, y vars, press 1 for function, and 1 for y1. Okay, that's how you get that. All right, so it's asking us then to describe the correlation. Okay, we want to describe the correlation. When you are asked to describe the correlation, you need to give 2 adjectives. One adjective will either be the word positive or negative, and the other adjective has to do with strength. It's very strong, it's weak, okay, something like that. Okay. If the R value is a positive number, then that means the correlation is positive. Had this R value been negative 0.92, then we would have categorized it as being negative. Okay. Now when it comes to the strength, you can look up above here and see where we think 0.92 falls in this chart. Okay. If the R value is exactly 1, okay, if it is exactly 1, then we're going to say the correlation is perfect, and that means all your points were in a perfectly straight line. Okay. If the R value is either 0.9 or less than 0.1, somewhere in between there, we're going to say that it's a strong correlation. Anything between 0.8 and 0.9, we're going to call it fairly strong, and then anything smaller than 0.8 is weak. Okay, so the closer it gets to 0, the weaker the correlation. Okay, so 0.92, that's falling right in this window, so we're going to say that this is positive and strong. Okay, positive and strong. Okay, so now I'm just going to go back to the calculator real quickly here. I want you to tap y equals, and I want you to see that the calculator did in fact take the equation and it did store it into y1. Okay, so if you were to hit the graph button, you now are not only seeing the scatter plot, but you're seeing that line of best fit kind of run right through your graph. Okay, once you have the equation typed into y1, you now can start answering prediction problems. Okay, and here's what I mean by that. If you look at part B here, it says predict the percent of households with internet in the year, let's do the year 2013. Okay, not sure why we've got two different things here. Okay, I don't know, this isn't responding. There we go, okay. So we'll predict for the year 2013, which was still in the past for us here. Okay, now please keep in mind that when we make this prediction, okay, think about how many years since the year 1995 the year 2013 was. Okay, that is technically 18 years after the year 2013. Okay, so here's how this works on the calculator. I'm gonna have you go into the table, hit second and the graph button. And what you're gonna see here, and your table might look different than mine, these are all points that are on that line of best fit, okay? This is the x value, this is the y value. We're interested in an x value of 18 because 18 years after the year 1995 would be the year 2013, okay? Now I'm pretty close to 18, I could probably just scroll there if this will let me. But a feature that's great is this table setup feature. You can hit the second button followed by the window key. You can control where you want to start your table out at. So let's start it out at 18, and then we'll go into the table, second graph. That way it has jumped right there for us. We're looking at about 92.83% of households, 92.83% of households had internet access in the year 2013, okay? Now, anytime a problem asks you, how accurate do you think your predictions are? That all has to do with how strong the correlation. If your correlation is strong, then you can say they are very accurate. If our correlation fell in the fairly strong category, well then we would say that our predictions are fairly accurate. If this was weak, we would probably say our predictions are not very accurate at all. Okay? I'm going to just run you through very quickly one more example on the back of this notes page. Okay? This is comparing 6 consecutive years. Okay, we're just calling it year 0, 1, 2, all up to 5. And the price in thousands of dollars of a privately owned single-family home. Okay? So just so that I can put this data in easily, I put my X's in L3 and I put my Y's in L4, but you could clear out your L1 and L2 data. You could put these in L1 and those in L2, okay? Now I drew the scatter plot there for you already, but if we were making, you should always make it on your calculator. I'm gonna go back into stat plot. I'm gonna choose plot 1. For me, I put this data, oh here, let me start back at the beginning. Press the stat button, press 1 for edit. If you're gonna clear the data out of L1 and L2, move the cursor on top of L1, press the clear button and the down arrow. Okay. You can see that I typed the data already into L3 and L4. So since I'm using those lists, when I go into stat plot, I'm going to need to change and tell the calculator L3 is where my X's are, L4 is where my Y's are. If you're just going to put them in L1 and L2, you shouldn't have to adjust that at all. Okay. Then we're going to go into the window. We need to totally readjust our window. The smallest X value was 0, so I'm going to go a little bit smaller than that and say -2. And the highest X value was 5, so I'm going to go a little bit higher than that and make my X max 7. Okay. My lowest X value was 154, so I'm going to go 150, and the highest was 273, and I think I'm going to count by 20s. Okay. Now, before I hit graph, I'm going to go into y equals. I want to wipe out, clear out that old equation from the previous problem. I'm going to press graph. This definitely looks like it's got a positive correlation. Looks pretty strong there. Okay, now let's go ahead and run the linear regression. The black stat key, the calculate menu, picking option number 4. Okay, if you've got an older calculator, this is where you're going to do L1, comma, L2, comma. Most of you will just leave this L1 and L2. I, again, have changed it because L3 and L4 are where my data is at. But you always have to make sure that you tell it where to store the regression equation. So after that last comma, if you've got an old calculator, you're going to put Y1 there. Newer calculator people, you're going to put Y1 here. Vars button, Y vars, 1 for function, 1 for Y1. Come down, hit enter. You're going to round A and B to 2 places and write it in equation form. Round the R to 2 places, 0.98. Okay, so the equation that we would write down would be y equals 23.06x plus 144.36, an R value of 0.98. When it says to describe the R value, you're going to look at that chart on the front. Okay, this number here is a positive number, so I'm going to say it's positive correlation, and it falls in the category of being strong. Okay, let's do this prediction here. Okay, the prediction is what's the selling price for a new home at year 8. So on the calculator, I'm going to go into table setup. I'm going to start the table out at 8. Then I'm going to go into the actual table, and right across here, I see that it would roughly be $328,810. Okay, about $328,810. Okay, how accurate? Well, we said it was strong, so we're going to say very accurate is how confident we are in our prediction. Okay, all right.